Alright, I'm going to first explain it quickly, and then if you want like the in-depth explanation conceptually, just stay afterwards. So this is question 10 for homework physics. So you know how to calculate force. It's mass times acceleration. But what you must know for A is that these pulleys are essentially making the amount of force you need halved. So you would take m times A is just gravity, of course, and divided by 2. So then for B, note this is one very important thing that I must stress. Pulleys do not reduce work. They do not. The work is still the same. So if your force is divided by 2, that means your distance is multiplied by 2. So if I try to pull at 3.5 centimeters, I will have to pull down 7 centimeters. I'll explain why later. And for C and D, work is just asking for the work. Work is just force times distance. So take A, times it by your B, and gravity is always negative, so D will be negative. Well, in this case, we're defining gravity as negative. So then you just take A, the answer from A times the answer from B, and it'll give you a C and D. Now for the explanation, why in the world, in this case, is the pulleys making the force 1/2? Well, think about it this way. Tension always opposes, I guess, gravity in this case. Assuming you were just holding on to it. So tension, we all have to agree, would be pulling up. If it's not, this block would start falling. So notice that these two tensions are not the same. These are two different tensions. Why? Because they're both going up. If they were the same, this arrow would be going down, and this arrow would be going up, and this wouldn't be saving us any work. So essentially, the gravity is being split between two different tensions. And since the force is equal to your total of your tensions, and your force is equal to m times g, your two tensions equals m times g, and your force just needs to match your tension. So force is just, if you divide both sides by 2, because force is equal to tension, as we know, force just equals mg divided by 2. And this is why we also need to pull twice as far. You could try thinking about it this way. Imagine, as I illustrated here, there is no second rope here. It's just this. There is only one tension. So your force is directly equal to it, so this does not help you at all. And also, if I was to pull this down by 1 centimeter, this would have to go up by 1 centimeter. Like if this goes up by 1 centimeter, this goes down by 1 centimeter. So the total change is just 1 centimeter to move the block up 1 centimeter. But then let's go back here. Here I'm showing the length of the rope, not the force. This is the length. So imagine if I wanted to move this block up 1 centimeter. This one would have to go down 1. We all know this would have to go up 1, so this would have to go down 1. And what about this? How far does this go down? You may think it also goes down by 1 too, but you have to think about it mathematically. This, whatever this goes down by, has to equal the total of the change of these two arrows. Because if it doesn't, where did the extra rope go? If this goes down by 1 centimeter, and then this goes up by just 1, and this goes down by 1, where did that other centimeter go? It can't just vanish. So, if this goes down by 1, so this is pushing it up like 1, and this also pushes up by 1, the total change here needs to be them added together, or 2. And since work equals force times distance, and the work is the distance is essentially, change in distance is essentially doubled what you need, then that's why your force is 1/2. Also, this happens to answer B, because to move this up by 1 centimeter, you need to pull this down by 2. And if I had a third pulley, basically you would have 3 different arrows, and then this would be 3 times less, and so on and so forth.